Hello, Mr. Stolle here from your tutors. So today we are looking at a question, one of the hyperbolic function question. So it reads the line y equal to x plus 4 is an axis of symmetry of the graph of f of x equal to negative 2 over x plus q. The graph of f casts the x-axis at a. Now, so what we see in this graph, just for a reminder, we know that the general graph here is equal to a over x, what we call plus q. Now, what we know is that from this q becomes our asymptote. Okay, it becomes it's our asymptote. That's what you must remember. Asymptote. Okay, and a graph of this, when you're looking at the axis of symmetry, equations of axis of symmetry, the positive one, because remember it have two axes of symmetry, the positive one with the positive gradient is going to be equals to x plus q, and the second one is equals to y equal to negative x plus plus q. So these are general this is general formula for the axis of symmetry. Okay, equation of axis of symmetry. Now let's read the questions here. Write down the value of q. So value of q here, we know that this is an asymptote for for our graph, which is the y asymptote, and in this case here we can pick this value by looking at the this equation. So from this equation you have got the y-intercept. So this one here is our y-intercept. If you remember from lecture one, first class or lesson 1 of functions, we actually spoke about this. So this is a y function, y value, and it means that it's a y-axis. So y is equals to 4 there. So our q is actually equal to 4 because this line here, y equals to 4, is actually an asymptote. So here our q is equal to 4. Now, write down the equation of f. Now, once we have the equation of f, we are now able to substitute in the equation. So here, f of x is equal to negative 2 over x plus 4. Okay, so that's what we have. And state the domain and range of f. Now, looking at the domain here, I would like to write, I think here, in terms of the domain, and range. Let me just write domain here. And when this domain, remember we are looking at x values, okay? X values that can be occupied by the graph. So when we look at this, we see that the graph cannot touch y equal to 0 there because the asymptote here is y equal to 0. So what we can say in this case here, we are saying x not equal to 0. So here we say x element of real numbers, okay? X element of real numbers, but what is it? X cannot be equal to 0. So when we say x cannot be equal to 0, we are referring to the y-axis, which cannot be touched by the graph, okay? So in terms of x, it can go up from positive infinity, from here 0 up until positive infinity, or also from this point here 0 to negative infinity, but it cannot cross the line y equal to y equal to 0. Y equals to y-axis, sorry, the line, the y-axis, or x equal to 0. So here, now let's look at the range. The range now, it has to actually now tell us about the values of y that can be occupied by the graph, that can be approached, or I would call cut, or passed by the graph. And these values here exclude what called 4 only, but the rest of the values can be approached by the graph. So what we see here is we are saying y is also element of real numbers, but what we are saying here is y cannot be equal to 4. Okay, that's how we determine the range. That's also how we determine the domain. So we just exclude the asymptotes. So here, when you're defining a domain and range on both, you must make sure that you exclude asymptotes. Okay, asymptotes are lines or points that are approached by the graph but never touched. So it's only approached but never touched by the graph. So here we have the domain and the range, so we are fine. So for which values of x is f increasing? I think you now know that when we're talking of increasing, we are talking of a positive gradient where your equation, you have got a positive gradient. What we see is that from on hyperbolic functions, they can only be either increasing or decreasing. They can't be both. So what we see in this case here, this is an increasing, this is also an increasing, because the line, if we are to put any point on this line here, be it at this point, be at this point, our gradient will always be positive. The same applies when you go down to the other line here, the other part of the graph here. We also see that it's going to be the same thing because it is an uphill situation. So we are saying for which values of x is f increasing, we are actually talking what is it of the domain. So we are saying x element of real numbers. So it's actually defining the same thing here in this case as a domain, x element of real numbers, but x cannot be equal to 0 because that's what we see. That's what is happening here. It cannot increase where what called x is equal to 0, meaning to say it cannot touch the y-axis. Now, write down the equation of the asymptotes. So the asymptotes here, we now have them from my explanation. I think you can see now that equation of asymptote, one of it is actually x is equal to 0, and the other one in terms of y equal to 4. Then write down the equation of the axis of symmetry, what called the other axis of symmetry, What we see in this graph here, we are given the positive, what called axis of symmetry. So in this case here, we are given this positive one. So this one with a positive, but we are not given the one with a negative gradient. So, and this line again will still pass at this point here. And what do we know about it? We are going to say, okay, our line is equals to y equal to negative what you call x plus 4. That's the axis of symmetry, because we know that we just put the negative here and they still retain what is it, the value of q. So we're just checking here. You can see if it's a positive one, we have got x plus q, and if it's a negative one, just negative x plus q. So the q there remains, or you keep the q with its sign. Okay, so whatever sign that you will be having, whether it was minus 4 in this case here, we still keep that minus 4. It does not change. Okay, so hope you understand, guys, and remember what call this thing that we have taught each other. Thank you so much. Until next time.